This is a basic video in which we will be discussing some identities, and I am assuming that you have seen these identities earlier. Now, what does identity mean? It means equality that holds true for all values. So, in all of these identities, left hand side would be equal to right hand side for all the values of A, B, and C. Now, this first one is pretty basic. A plus B whole square is A square plus 2AB plus B square. Now, this is nothing but A plus B multiplied with itself. You open the bracket and you will get this expansion. Next, you put minus B in place of B. You will get this one. A minus B whole square is equal to A square minus 2AB plus B square. Now, combine these both. We can write A plus B whole square is equal to A square plus B square. Now, A square plus B square I can get from this one. A square plus B square is A minus B whole square plus 2AB. So, this is A minus B whole square plus 2AB, and this 2AB will become 4AB. So, this is also one of the way to write the same thing. Next is A square minus B square is equal to A plus B into A minus B. And similarly, we can write A to the power 4 minus B to the power 4. And this could be written as A square whole square and B square whole square. So, this would be A plus B into A minus B into A square plus B square. This is A square minus B square, and you multiply it with this, you will get A to the power 4 minus B to the power 4. Next, we have A plus B plus C whole square, which is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Now, this one is important. Actually, all of these are pretty important. A plus B whole cube is A cube plus B cube plus 3AB into A plus B. You can also remember this as A cube plus B cube plus 3A square B plus 3AB square, which you will get after opening this bracket. But my advice is to remember this identity in this form only, because here when you have plus sign in the left hand side, there would be a plus sign in the right hand side at all the places. So, we can write A minus B whole cube as A cube minus B cube minus 3AB A minus B. When there is a minus sign in the left hand side, there will be a minus sign at all the places in the right hand side, except for this A, it is positive only. Okay. Now, next is A cube plus B cube, which we can get from here also. A cube plus B cube. Take this 3AB into A plus B to the left hand side. Take A plus B common outside the bracket, and you will get A plus B into A square minus AB plus B square. So, this is what you will get finally. Next is A plus B plus C whole cube, which is equal to A cube plus B cube plus C cube plus 3A plus B, B plus C, C plus A. Now, this is not that important for you to remember, but you can easily keep it in mind, because this is pretty similar to this one, A plus B whole cube. Here we had A cube plus B cube. Here we are having A cube plus B cube plus C cube. Now, here we had 3AB into A plus B. Here we have 3 into A plus B, B plus C, C plus A. Pretty similar, right? Last but not the least, A cube plus B cube plus C cube is equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA plus 3ABC. Now, this formula is okay, not that important. What is more important is a deduction from this formula, that when A plus B plus C it becomes 0, when this is equal to 0, 0 multiplied by this one, this whole will become 0. So, what remains is 3ABC when A plus B plus C is equal to 0. So, A cube plus B cube plus C cube will be equal to 3ABC when A plus B plus C is equal to 0. This is pretty important, because very simple yet tricky questions could be made using this property. You will be given a question like 67 cube minus 41 cube minus 26 cube, and 4 options would be there. Let's say 45, 39 and 65 and 71. Which of these 4 options would divide this expression 67 cube minus 41 cube minus 26? So, this is nothing but a cube minus b, a cube plus c cube format, where a is 67, b is minus 41, c is minus 26, and you add these a plus b plus c, the sum will become 0. So this is nothing but 3. This is equal to 3 into 67 into 41 into 26, 3abc. So this 26 has a 13 in it, 13 into 2, and 13 multiplied by 3 will give 39, which is the final answer. 39 will divide this expression. Okay. Now what if you have to expand higher degrees? Let's say a plus b whole raised to power 4. For that we will use Pascal's triangle. What is Pascal's triangle? Well, this is Pascal's triangle. In the top we will write 1. At this position we will write 1. Now treat this 1 as having a 0 in the start and a 0 in the end. Add these two, 0 plus 1 is 1, and this 1, the sum of these two above terms will come at the bottom between these two numbers. So 1 will be coming here, and 1 plus 0 is 1 again, this 1 will come here. So at these two places we will have 1 and 1. Again treat these ones as having a 0 at the start and a 0 in the end. Again 0 plus 1 is 1 and 0 plus 1 is 1. So at these two places we will have 1 and 1. And at this place we will have 1 plus 1, that is 2. Next in this row also we will have 1 and 1 in the start and the end. So in each row basically we are having 1 at the start and 1 at the end. And 1 plus 2 will be 3, that will come here. And at this place also we will have 1 plus 2, 3. In the next row also similarly we will have 1 and then 1 plus 3, 4, and then 3 plus 3, 6, and then 3 plus 1, 4. And similarly we will have the last row as follows. Now this row denotes coefficients of all the terms in the expansion of a plus b whole square. Look here, this is nothing but 1a square plus 2ab plus 1b square. When nothing is there, 1 is written. And here also we have 1, 2, 1. So these are the coefficients that we got through Pascal's triangle, 1, 2, 1. Similarly, this row denotes coefficients of all the terms in the expansion of a plus b whole cube. Here we have 1, 3, 3, 1. Here also we have 1, 3, 3, 1. So from this logic we can say that this row will denote coefficient of all the terms in the expansion of a plus b whole raised to power 4. So the coefficients will be 1, 4, 6, 4, 1. Now what about the remaining thing? What about the powers of a and b? Look here, when the power at the binomial term was 2, in the expansion we had degree 2 for all the terms. Now what do I mean by degree? Degree is nothing but sum of all the exponents in a particular term. So here we had degree 2. Here we have exponent 1 and 1, so sum of exponents is nothing but 2. Here also we have degree 2. Now when the power was 3, we had degree 3 for this term, 2 plus 1, 3 for this term, 1 plus 2, 3 for this term, and 3 for this term as well. So in each expansion we start with A, or the first term, having the maximum power and B having the minimum power. Here the power of B is 0, B raised to 0. And then in each subsequent term, we reduce power of A by 1 and increase power of B by 1, keeping the degree of each term constant. So this will expand as 1 A raised to power 4 plus next coefficient is 4. 4 A cube B plus next coefficient is 6. 6 A square B square plus next is 4. 4 A B cube plus next is 1. So 1 B raised to power 4. This is what the expansion of A plus B whole raised to power 4 will look like. Now there are a few interesting things about this Pascal's triangle, that sum of numbers of a particular row will give powers of 2. This 1 is nothing but 2 raised to power 0. Then we have 2 raised to power 1. Then 1 plus 2 plus 1, that is 4, 2 raised to power 2. 1 plus 3 plus 3 plus 1, that is 8, 2 cube. and this will give us 2 raised to power 4. This sum will be 16, right? Then we have a few number patterns in this Pascal's triangle. These are all ones. In this next slant row, we have natural numbers 1, 2, 3, 4, 5. And then we have these numbers 1, 3, 6 and 10, which are called triangular numbers. Why are they called triangular numbers? Because they can be stacked up in form of triangles like this. Also, these numbers are of the form n into n plus 1 by 2. That is sum of first n natural numbers. This is 1. Then we have this 3, that is nothing but 1 plus 2. Then this is 1 plus 2 plus 3. And this is 1 plus 2 plus 3 plus 4. Also, there is one more property associated with triangular numbers. You take any two consecutive triangular numbers, add these. 1 plus 3 is 4. That is a perfect square. 3 plus 6 is 9. Again a perfect square. 6 plus 10 is 16. Again a perfect square. So add any two consecutive triangular numbers and you will get a square number. Next we have these numbers 1, 4 and 10, which are called tetrahedral numbers. These are called tetrahedral numbers because these many spheres can be stacked together to form a tetrahedron. Look into this figure. The first layer has 1. So a number 1 is there. Next, if we take these two layers, first and second row, 3 plus 1, 4. So 4 is yet another number in the series. And then we have 6 plus 3 plus 1, that is 10. 10 is again a number in the series. So these are called tetrahedral numbers. We'll stop with the Pascal's triangle here. These triangular numbers that we have seen 1, 3, 6 and 10 are pretty important from CAD's point of view. We'll see them in detail in progressions chapter. In the next video, we'll solve a few questions based on these identities. Subscribe and hit the bell icon so that you get notified when the next helpful video is out. Thank you for watching.